So welcome to review our execution flow. What we're going to do in this video is take a look at a diagram of the whole elevation execution flow so that we can just get the big picture. I feel like we're really stuck in the details. We need to zoom out a little bit and make sure we understand what's calling what and what eventually is leading to the request for the barrel to elevate or go downwards. So let's take a look at that. Okay guys, before we go any further than this, let's just take a recap of how this barrel's elevating because there's quite a long call stack. So the player or AI controller makes a call to a method called aim_at, passing in a hit location, which is a world space location, right? And it sends that to the tank. So it says, tank, aim over here in the world. The tank goes, fine, I'll use my knowledge of the launch speed of the projectile to then pass that method on to my tank aiming component. I'm not going to deal with it myself. I'm going to delegate it down to the tank aiming component, but given my launch speed. The tank aiming component then calls elevate with some relative speed. Now, I know that right now the tank aiming component's method is, the barrel's method is elevate, and let's just take a look at the signature. We have degrees per second. That's actually wrong, so I will change that. I'll just change it right now, actually. What it should be is relative speed, and let's see why. So if we look in the tank barrel implementation now, if we look at, well, you can't really tell from the implementation yet, but the point is that you can tell from the header file because the tank barrel has a concept of a maximum number of degrees per second. So you could pass in a number of degrees per second. That would be okay, and then you could clamp it to this maximum. Or, in my mind, it's more meaningful to just pass in a relative speed where -1, in fact, let's comment this as we go. So -1 is max downward movement, and +1 is max up movement. Okay, that's the idea. So that's what I mean by relative speed. It's between -1 and +1. If we give it a value outside that range, it'll just treat 2, 3, 4 as 1. It'll clamp it down. All right, so that's what I want to do is call it relative speed. Okay, let's go back to the overview. So the aiming component calls the barrel with a relative speed. The barrel uses its knowledge of the maximum number of degrees per second it can move at, its maximum elevation in degrees, I think we set it to 40, and the minimum elevation in degrees. Now remember, we set sensible defaults on those here in the C++, and then we also, if you recall in the tank blueprint, made it possible for the designer at the barrel here to come and tweak those values. Fantastic. So if I just go back to the slide, that's an overview. The other thing to note is that the tank player or AI controller, they both tick. They both have a tick method. And what they do is they just update the aim every frame. The tank actually doesn't need a tick, and we'll go through and take a look at that in a moment. And the tank aiming component does need a tick. Now you might say, why does the tank aiming component need a tick? Why couldn't it just tell the barrel where to aim? Well, think about the situation where an AI tank is aiming at me. I'm the player, I'm sitting at the origin, for example, I'm not moving, but the AI tank is moving. And as that AI tank moves, its hit location value up here will not change because my world space location is not changing. But the barrel and the turret will need to move as the AI tank moves in order to constantly adjust its aim to be able to hit me. The tank could be in a different position, it could be on a hill, etc. So the tank aiming component does need to tick. It does need to calculate things every frame. All right, to instruct the barrel and the turret where to move. So let's go through and just make sure this is the case before we do anything else, that the player controller ticks. So let's go take a look at that code. And the tank player controller.h, does it tick? There is a tick declaration there, but that doesn't mean it's actually ticking. And then if we look in the method, here you go, tick, and every tick it aims towards the crosshair. Fine, so that's what it does. Let's move down the stack to the tank. Well, what does aim towards crosshair do? It does some things and then gets the control tank and says, hey tank, aim at this. So we go to the tank. Now, does the tank have a tick? Well, the tank tick is declared here in the private section of its header file, but if we actually go to the tank implementation and we look at the tick, you'll find that it's empty. Here we go. So let's remove tick from the tank. Let's do that by removing the tick method from the tank CPP. In the constructor of the tank, we can explicitly say don't tick. We can say can ever tick equals false. It says you can improve efficiency if you don't need it. So let's stop the tank ticking. And then in the tank.h file, we don't even need to declare this tick method. Now, because I've made these changes, let's go ahead and compile the code and make sure that we haven't busted it. Just give it a second to compile. And then we will continue down this stack, looking at the tank aiming component, making sure that does have a tick structure, and then just double checking that the barrel doesn't. And that way I've got a compile failure. Degrees per second undeclared identifier. So I love C++. It's my favorite language. And one of the reasons it's my favorite language is because you have to do things like this. You have to go and change things in 2 places. And where is this other place? So somewhere I'm calling elevate. Well, I don't need to guess where that somewhere is. I'll be calling it from the tank aiming component, won't I? Because we know our architecture. So in the tank aiming component, where am I calling that? Okay, I've given up. I'm going to read the error message. It's in tank barrel, line 11. There we go. And it's here, this degrees per second. It's just our log entry. Simples. Okay, let's go ahead and compile and see how we're getting on. So, as I was saying, we are now just making sure that the changes we made to the AI controller and the tank are actually working and that the game still works as well as it did before without that tank ticking. Seems to. It still keeps calling out the barrel elevate. Now, how do we know, by the way, that it's continually calling that? Is it continually calling that? Well, we'll look at that in a moment, possibly in the next video. There is actually a bug with one of the methods in here. But the way to find if something is actually being called is it's very useful to know about this. You go auto, and then you go get the world, and then you go get from the world, there's a time. Now, autocomplete on here, of course, is not behaving for me. I think it's get time, but I'm not sure, so I'm just going to check my stash here. I've got a note in here, and if I can find it, get time seconds, it is, okay. Not sure why autocomplete's not behaving, so if we get time seconds from the world, now we have a floating point. I need to give it a name, that's my problem. Time equals get world, get time seconds. Perfect. Now time is a float, so it's very easy for me to just come in here and go %f colon, and then put in time as the first formatting parameter. So this %f matches with the time, and this one matches with the relative speed. Now when I play the game, my logs will be beautifully endorsed or annotated or decorated, I think is the word I'm looking for, certainly not endorsed, with a prefix which tells me the time at which that log entry was made. And that's much more encouraging because we can see now that the logs are actually happening. All right, so the code's still ticking. Let's go back to our overview. Does the tank aiming component have a tick? Well, let's take a look. We're saying here that the can ever tick is true in the tank aiming component, but we don't have a tick method defined. And actually, we need to challenge the question, do we really need this tank aiming component to tick? Well, we haven't written any code in the tick yet. We've still got it as true here. We're kind of undecided. I'm telling you in the architecture it does need to tick, but maybe it doesn't. What we need to do is to really find out whether it needs to tick. And looking at the length of this video, we're going to do that in the next video as we go through and discover how to squash a bug in the Unreal Engine and probably report it to Epic Games as well because it's a nasty one. But for the moment, if you have something like a question to yourself that, should this tick, then just go to do. Should this really tick? ? All right. And then what I will do is I'll pop on the slides even for you that tick ? So we can just raise that question and move on. All right, the final thing is at the bottom of the stack, which is the tank barrel. In the tank barrel.h, there is no declaration of tick. In the tank barrel.cpp, there's no mention of tick. And you need to ask yourself the question, is the tank barrel now ticking or not if we don't explicitly disable that tick? So in the case of this tank barrel then, if we look, it inherits from static mesh component. You'd find that if you did put a tick function in and put a log, that it would actually print, which means that the static mesh component may well be ticking above. But look, just leave these things when you create a new class at default. If there's no reason to turn off the ticking or to turn on the ticking, just leave it. There's no point in putting extra code in. If the performance profiler later told us that we were wasting a lot of time ticking here, very unlikely by the way, then we could do something about it. So I'm just going to leave the tank barrel as is, keep it nice and simple. Okay, so that's an overview as to the call stack that's occurring. So what we need to do now is to actually get this barrel moving. So let's just take a look now that we've got these new log entries and just see some slightly odd behavior. Look at this. As I move the mouse around, if I leave it there, watch, the logs are happening. The elevate method's being called. But if I just move, and there, it's not. Now, you may think that's because it can't find a solution. So one reason it would not tick like this is because there's no solution to the aiming solve. So let's go to where we do the aiming here. And where it says aim at, we could say, okay, there's an aim solution. If we have a solution, then move the barrel towards an aim direction, which in turn calls this elevate method. But if we don't have a solution, let's just log something out here. And let's use this new logging method. Let's log here. No solution found at this particular time. No aim solve found. Okay, now I don't really like logging at two different levels of detail like this. If we're going to log no aim solve found here, rather than logging in the tank barrel that the elevate has been called, we know that elevate's getting called. I'm going to move that and do the logging at a consistent level. Keep all our logs in one place. So if we have an aim solution, then it would make sense to log, say, here. And then I'm just going to say aim solution found at a particular time. Okay, so I've moved all my logging just inside the aim component to find out when we do and when we don't get an aim solution. Let's take a look. Oh, I didn't compile. That would help. So let's just compile it up, and then we're going to just take a look and set ourselves up for, unfortunately, a bug in one of these methods. Now, partly it looks like my fault, but actually it isn't. We'll see when we get to it. So what's going on here? No aim solve found. Why can't it find an aim solve most of these frames? Why is it only finding a solve one in a few frames? Very well if I point at the sky, of course it can't find a way of hitting that, and if I point at that mountain in the distance, it's just too far away for my current projectile velocity. But why on the floor here will it only find a solve some of these frames? Well, that's a very good question, and one we'll address in the next video. So I'm not going to deal with that right now. What I'm going to do is something slightly different for this video. I'm going to close down Visual Studio and Unreal for you, and then I'm going to use my code management tool here in SourceTree just to show you what's changed in this video so that you can see the code changes I made, because I made a few code changes, and this will be really easy. So now you should be able to step through the video, pausing if necessary, and seeing exactly what I did. So in the tank CPP, I disabled the tick. The green is what I changed. I also just removed the tick function from the tank CPP itself. In the tank aiming component, we made ourselves a note to question whether it should tick or not, and then we did that logging. And by the way, if you like this, tell me either on Facebook or our forum or in the Q&A, which doesn't really quite fit for comments, but if you wish, put it there on Udemy, and just say whether you like me reviewing what we did this way, because it's just a new thought I had. In the CPP file, we just removed some logs and that log there and made a variable name change. In the tank header file, we also removed the tick. And in the tank barrel, we just changed the name of the parameter here from degrees per second to relative speed. And we also commented that -1 means max downward and +1 means max upward. And we did all this in the context of this diagram, which helped us understand what's going on. And in the next video, we'll discover, or get you to discover, what's going on with this inability to solve the aim in certain situations. So I'll see you soon.